Hello dear students, welcome to Gate Academy Global. As you guys are well aware, we have come up with the series with the control system. Not only control system, the various subjects are going concurrently, and there we are discussing the concept of the question. So without getting delayed, let me focus over the questions which we are going to take in today's session. Obviously the questions would be coming from control system and the basics of the control system. So around 9 number of problems we are going to take in today's class. This has been the glimpse of the first question. In the same sequence, we'll go into the second, then we'll go into the third, fourth, fifth, sixth, seventh, eighth and ninth. Total 9 number of questions I have planned to take in today's class. And the topic which we are going to cover in today's class is gonna be the first topic, which we would be covering with the help of the questions. That's nothing but the basics of the control system. Once we are done with the basics of the control system, we are going to take few number of numericals based on the concept of initial as well as final value theorem. Initial as well as final value theorem. Yeah. Divya P, good afternoon. Good afternoon, dear. So let me focus over the first question, read this problem carefully and try to give the best most answer whatever we can get out of this particular problem. So you have to read by your own and then you have to give the proper most answer whatever we would be getting after solving this problem out. Tell me what would be the best most answer for this given problem. The problem states the transfer function of a linear system is the options are given as a ratio of the output V naught t and the input V in t, ratio of the Laplace transformation of the output and that of the input with all initial conditions 0, ratio of the derivative of the output and the input, none of this. Tell me what would be the precise most answer for this given problem. What would be the precise most answer for this given problem? So I would be waiting for the response from each one of you. And once you are done with this problem, definitely I will give you what would be the best most answer for this given problem, and I would try to explain a bit wherever technical details are getting involved. Technical details are getting involved. So we have started getting the answer. So as per the Satish, the answer is B. As per the Gayatri, the answer is B. As per the Pranali, answer is B. Anyone else apart from the 3 answers which we have got it? And I would request to each one of you, I want your proper participation. Whenever I show the problem, I want the answer from each one of you. Whether the answer is correct, whether this answer is wrong, no worry. End of the day, I am here to teach each and every technical details. Each and every technical details. So now the Nissan Sharma says the answer could be A as well as B. The answer could be A as well as B. Tell me, anyone else apart from the 4 to 5 different answers which we have got it over the live chat? Manisha says B. Susmita says B. Biaptron says B. So almost all of these students had got the same answer and that had been B. That had been B. Obviously, the B is gonna be the best most answer. And the B is gonna be the best most answer. Anyways, let me bring this problem towards working board and let me briefly discuss about its technical detail. From where the concept of the transfer function have come into the picture. I was trying to discuss in yesterday's class, but still let me discuss briefly in terms of control system. See what happens when you have a system and if the system is being excited by the certain input, may you know what used to be the output? Output used to be the convolves between the input as well as its transfer function. So what I am saying over here, I have taken an example. Here we had a system which has been excited by certain input. Let's take the input is being R of t and similarly the output is being C of t. Let's take the output has been C of t. What does that mean by the C? C stands a function and t stands being a function of t itself. That means that everything has been given in time domain. And let's say the system in time domain is being defined as h of t. May you know what would be the value of C of t? The C of t is not only the multiplication between R of t as well as h of t. Anyways, we would understand this concept in the case of signal system. It used to be the convolution between the input as well as the system behavior with respect to the time, how it's been changing. But what happens? This analysis becomes very difficult. Whenever you have a system, the system gets convolved with the input and becomes its output. This analysis becomes very, very difficult. So that is why most of the time the system analysis is being done in Laplace domain. Why? Because when we would go into the Laplace domain, no, R of t would change to R of s. We have seen how it's been. Similarly, h of t would get changed to the capital H of s. For the time being, I may also write this as a t of s, and now the c of s, which was the convolution between a small r of t as well as a small h of t, would get converted into the capital R of S into of T of S. T of S. So you yourself would be able to understand the transfer function T of S is just a division between the output in Laplace format divided by the input in Laplace format. So one of the student, probably the Nissan Sharma, has given the answer. The transfer function could have been written as the ratio of the output to the input in time domain, which is utterly wrong. Why? Because in time domain it has been a convolution. It's not only a multiplication where the R of t and H of t is getting multiplied. No. And if it is been a convolution, you cannot just shift this R of t towards left hand side. No, you can't do that. But in case of this complete problem has been shifted into the Laplace domain, definitely the CS as well as RS ratio can be taken. So if somebody would say, sir, it would be the ratio of output to the input in time domain, I would say it is a utterly wrong assumption, because the output used to be the convolution between the input as well as the system performance with respect to the time, and now R of t cannot be brought towards left hand side as a divisor. No, we can't do that. But once we take its Laplace, obviously the convolution gets converted into the form of multiplication, and as this process takes place, or the Laplace follows this property, that means now the R of t has become a R of S, H of t had become a T of S, and the convolution has become a multiplication. Now the T of S is just ratio between CS divided by RS. CS divided by RS. The student is asking, what about the concept of convolution? I think control system is not the right subject to discuss about the convolution. That part would be discussed in the great detail when we would be discussing about the signal and system. So Nishant, your answer has been ruled out. No, A can't be the answer. I would like to ask one thing from each one of you, whether the concept of the transfer function is only valid for the linear system or whether it's also valid for the non-linear system. If your response is only for linear, you should write only and only L. And if your answer is valid for both, you are saying, so the concept of transfer function is valid for linear and non-linear system both, in that case you should reply over the live chat as LN. L stands for linear, N stands for non-linear. Because in this problem specifically they have categorically marked over here the transfer function of a linear system. What I am saying, if the system is a non-linear system, can I get its transfer function or not? Nishant, at any case, the A is not the appropriate most answer. Whatever the reasoning you are giving, it is not at all applicable. Yes, except in state space analysis. My dear friends, Harsh Kumar, you should have a clear-cut idea. In case of state space analysis, we had got a relativity between the transfer function as well as state space. That means the transfer function can also be converted in a form of state space. That is for sure. That is for sure. But I wanted to know one thing. If a system, the system has been given to you, and if it's been a non-linear system, can I get its transfer function or not? Can I get its transfer function or not? No, I can't. So almost all of the answers which we have received over the live chat looks very pretty okay. Yes, a system has to be a linear system, then only its transfer function can be deduced, can be retrieved. Let me take an example. You will be able to understand the thing into the better way. I have taken a system in such, it takes the input as x of t, and the output y of t is just a squaring of the input. You can take a square law device. What does that mean by the square law device? Whatever the input goes in, just the square comes out. So what I am saying, I have taken a squaring device or square law device. Many of the times we use this device in case of modulator as well as demodulator. Let's take the input which has been applied is being x of t, and similarly let's take the output which has been received is being x square of t. As far as the transfer function is being concerned, it's been the ratio of output into the Laplace domain divided by the input into the Laplace domain. First of all, you should have a clear-cut idea. This system, the system which we have used for just sake of understanding, it's been a linear system or non-linear system. Obviously, it's been a non-linear system. Then only x of t is simply going to get squared, or maybe to the power of 3, maybe to the power of 4, so on and so forth. But for the time being, I have taken this as a square law device. So obviously, which system it has been? A non-linear system it has been. Non-linear system it has been. And now I would try to get its transfer function, whether it's possible or not, that we are going to see now. Yes. So now what is happening over here, you had to take Laplace both on the side. You had to take Laplace both on the side. So here goes y, which has been the output, is equals to Laplace of x square of t, x square of t. One of the worst thing which is happening along with this problem, probably you could have smelled it. You cannot get y of s as well as x of s exclusively. Although once you will take Laplace of y of t, you will be getting capital Y of s. But once you will take Laplace of small x of t, you won't get exclusive or loosed form of x of s, such that x of s could have been shifted towards left hand side. I could have got its transfer function. No, it's not possible. So it would be my homework. You guys had to get the Laplace of x square t. It would be in the form of Laplace of y of t, could have been written as y of s. I am happy with that. But once you'll take the Laplace of x square t, what's happening over here? Do you know that x of t has been raised to the power of 2, could have been written as x of t into x of t. And once the multiplication takes place in time domain between the two functions, the convolution takes place in Laplace domain. So what I am saying, xt into xt would get changed into the convolution, and end of the day, y of x divided by of x of s. No, you cannot get out of this. You cannot get out of this. So one thing is being quite sure. If you had a system which has been a non-linear in nature, that means it is just doing the squaring or maybe cubing or maybe quadrating. In that case, the y of s, x of s cannot be retrieved. And whenever the output to the input ratio in Laplace domain cannot be retrieved, that system would be ruled out for the analysis using the transfer function. Yes. Could you understand? So one doubt probably I can see over the board, what they have been asking, sir, why a LTI system alone? So out of LT, the L stands for linear, TI stands for time invariant. Probably I could have given a good amount of understanding why only linear system is being used for the transfer function approach analysis. Now let me focus over the time variant as well as time invariant. Let me go into the next page. I would like to ask the next question. The concept of transfer function. Again, I would like to ask one question. The concept of transfer function, is it valid for invariant system alone? Obviously time invariant system alone, or it is also valid for time variant system. So if your answer is only and only invariant, you should write I, and if your answer is for invariant as well as variant both, you can write I/V. So I would be waiting for your reply. So far one thing has been got fixed. Whenever we are going to use the transfer function approach, the system has to be a linear system. There is no other way. Non-linear system cannot be used. Invariant, or it could be invariant as well as variant both. Divya P says I. Anyone else apart from Divya P? So around 6 to 7 different inputs we have got it, and all of them are saying only invariant. Okay. So obviously the concept of transfer function approach is only been valid for the invariant system alone. So let me give an example, and from the example we'll try to understand why the invariant system itself is a system which can go ahead with the transfer function analysis. Let's take an example. See, I had an output from a system which had been x of 2 times of t. Before doing analysis over this sort of system, I would like to ask from each one of you which type of system it had been, whether it's been a variant system, whether it's been an invariant system, whether it's been a invariant system. Similarly, let's take this. This has been my first question. Let me go ahead with the second question. Y of t, it's just been the reversal in time domain of its input signal. It's been input signal. So I would like to ask from each one of you, question number 1 as well as question number 2, which type of system it had been. Obviously, many of the students who are not very well aware with the signal system would have a little bit doubt. Sir, how do you judge that it's been a variant or invariant system? That part would be dealt exclusively when we would be dealing with the signal system. Yes. Gayatri, you had to study a bit about the signal system, then you'll know about it. Obviously, both are the systems which we have used over here, no? It's been a time variant system. Yes. Both had been the time variant system. So what's been happening over here, just try to understand what I'm saying. Again, we have been search of finding its transfer function. May I know what used to be the process, what used to be the procedure? We used to take the Laplace transformation both other side. Yes, let me take that. If I take the Laplace transformation both other side, so small y of t would become capital Y of s, or I can say it had been the Laplace transformation of y of t. And towards right hand side, what it becomes, it would be 1 upon 2 of capital X s by of 2, s by of 2. And as I had said earlier, the Laplace transformation is nothing but the ratio of output to the input in Laplace domain. May I know what would be the ratio of y of s by of x of s? No sir, I can't. No sir, I can't. Why? Because here I am not getting x of s. I am not getting the output which has been the function of s. Here I have got the output which has been a function of s by 2. And when it would take place, it would take place everywhere whenever the t is going to multiply with certain value except 1. Could you understand what I am saying? Could you understand what I am saying? So what I am saying, whenever the t goes multiplication with any of the component, no, obviously the system switches from invariant to the variant system. And whenever you had the variant system, the y of t is going to connect something like this. And whenever this connection takes place, you yourself would be able to judge, yes sir, we cannot get x as a pure function of x and x as a pure function as s, and hence the division between y of s as well as x of s is not at all possible. Not at all possible. Could you understand what I am saying? Why the concept of transfer function approach is being valid only and only for the LTI system probably must be understood to all of us. The first question or the first example which we have taken, deliberately I have taken a non-linear system where the input was just getting squaring towards output side. So it was a square law device. Probably it's going to be a non-linear device. And once we tried to calculate its transfer function, we could not succeed. What does that mean of it? That means this sort of system cannot be demonstrated by its transfer function. That's the first thing. Not only that, even I tried to take a second kind of the system. Let's take, I had a system, the input has been x of t, but towards the output side, the output y of t was equals to of x within the bracket 2 times of t. What does that mean of it? That means there had been the scaling in time domain. I am not going into the great detail, but one thing has been quite sure. Now you have been dealing with the time variant system. And once you have been dealing with the time variant system, you yourself would be able to understand. Again, you are not able to calculate the ratio between output to the input in Laplace form. Would like to understand from each one of you. Is this concept is clear to all of us? So from here onwards, nobody should say, sir, why only LTI system is being chosen while analyzing the system into the transfer function domain. May I know what are the different topics uses the transfer function approach? All of the topics within the control system. It starts with the transfer function, goes to the signal flow, goes to the time response analysis for the first order, maybe second order, goes to the Bordes, goes to the Nyquist. Everywhere we use the transfer function approach. So everywhere the same problem is going to be prevalent. That means until and unless your system is not a linear system, not a time invariant system, you are not going to deal with the transfer function. If any sort of doubt you guys are having, no, you can keep ask. That's what I am saying. If you guys are having any sort of doubt, no, you can ask in between. Agreed? So with the simplest form of the problem, few of the critical aspects of the transfer function must have been clear to all of us. I know many of the students used to have this doubt also, sir. If you take the ratio of output to the input in Laplace domain, so why don't you take the ratio of output to the input in time domain? That's not possible, because here it's not the multiplication, it's been a convolution, and simply I cannot shift the r of t towards left hand side. So this has been ruled out. This has been ruled out. Ratio of the derivative, nowhere it's being connected to the real challenge of the problem. None of this. Yes. D. So till this point, each and everything must be clear to all of us. Now tell me, one additional information is also being supplied along with this problem. May I know what it is? The ratio of the Laplace transformation of the output to the input. It looks okay, but why additionally a few more information has been carried along with this option, and that's being all initial conditions must be zero. What I'm saying, if you had a certain initial condition, can't you get that the transfer function for that given system? What I'm saying, if you had a certain system, and that system may have a certain 2 or 3 number of elements which carries the initial energy, so can I get the transfer function of that system without dropping their initial conditions? Yes or no? Yes or no? What I am saying, here it has been clearly written, the initial condition has been dropped. So what I am saying, always we had to drop the initial condition, or without dropping the initial condition also we can get the transfer function for the corresponding system. If you say yes, always you had to drop the initial condition, your response over the live chat has to be Y. And if you say no sir, it is not required, in few of the cases without dropping initial condition also we can get the transfer function. So you should write N. You should write N. Nissan not required, not required. What I am saying, as per the Nissan, he is saying, sir, before studying control system, LTI system will be sufficient as a prerequisites. Even that is also not required. It would be my pre-assumption, whatever the systems which we are going to deal within the control system, it's gonna be a linear time invariant system. That's it. Nowhere you are going to discuss which kind of the system it's been, whether it's been a linear, non-linear, invariant, time invariant. No, not at all required. Not at all required. So I would like to have the input from each one of you, whether always it is required to drop the initial condition to frame the transfer function for that corresponding system, or sometime without dropping the initial condition also the things will move. The things will move. Sandeep Saha says the drop the initial condition. Pranali Ingle says yes sir, we need to drop it at any case. And similarly Divya P also states yes sir, we had to drop the initial condition at any case. Yes, my dear friends, just try to understand in this way. I was not happy while dropping my initial condition, because if you have energy storing elements like capacitor which can conserve the initial voltage, similarly inductor which can conserve the initial current, similarly you may have a spring, damper, mechanical system which can conserve the mechanical energy in the form of initial energy. But still there is no other way. Once you deduce the transfer function from any kind of the equation, there is no other way. You had to drop its initial condition, otherwise you would not be able to reach it to its transfer function. So this is not my choice, but by force, yes, I am always dropping the initial condition. My choice says no sir, why don't we carry the initial condition such that with the great accuracy we can find or we can analyze the system, but still there is a force that you had to drop the initial condition. So whenever the concept of the transfer function or the definition of the transfer function do come in your mind while studying the control system, the definition must be the option B itself. What it has been, the ratio of the Laplace transformation of the output to the input in case of all initial conditions is being fed to 0, and it's only been defined for the linear time invariant system. Although in this problem only linear word is being framed over here, but in future it is only valid for time invariant system alone. Time invariant system alone. Yes. So Gayatri had one doubt. We had to drop Y. Yeah, Gayatri had one doubt. Let me take her doubt and to the great extent. See what is happening over here. Let me take a series RC circuit, and from the help of, with the help of series RC circuit or RL circuit, we are going to analyze each and individual problem crisp and clear. See, we had a series RL circuit. Here we had a resistive element. had the worth of R, and similarly inductive element had the worth of L, had the worth of L. The external voltage is being applied. Let's take the voltage is being V. I'm not saying it's a DC voltage. I'm saying it had been a time varying voltage V of t, but for the just sake of better understanding, I have taken its polarity upside positive, downside negative, downside negative. But otherwise, you could have taken this problem into this form. Yeah. Let's take it's a plus minus V of t, and because of external voltage V of t, this loop experiences the current I of t. So if I would apply the KVL in this loop, may I know what would be the KVL? The drop across R as well as L would be equals to V of t. So simply I can write R, flow of current across the R, that's been I of t, L dit of dt, obviously dit by of dt, and that would be equals to V of t. And as in this particular problem, we have been looking for finding the transfer function. May I know how the transfer function would be? The transfer function would be the ratio of output into the Laplace domain, and that has been I of s, divided by the input into the Laplace domain, and that has been V of s. That's well and good, sir. That's well and good. So what we are going to do over here, we are going to take the Laplace both other side. What we are going to do in next step, taking Laplace both other side. Taking Laplace both side. Laplace both other sides. So R is been a constant value, has been brought out. The Laplace of I of t had been taken as capital I. Obviously, now the function has been changed to the function of s. And here it becomes L s capital I of s minus small I of 0. We have already discussed about this thing in the great detail when we were discussing in the last class. Here I would be feeding t is equals to 0 into the small I. And here it becomes V of s. And as per the need, we have been looking for the ratio of I of s as well as V of s. Whether it's possible or not. Gayatri, I would like to ask from you whether the ratio of IS as well as VS is being a possible or impossible. The reply has to be in a form of P or I. It's impossible. Why it's been impossible? The ratio between IS and VS can be achieved only and only if each and individual term had IS or VS. Like this term had the IS, no issue with this term. This term had the IS, no issue with this term. But this term did not have either the I of S or the V of S. What does that mean of it? That means if this term is being live, you cannot get the ratio between Vs as well as Is. And similarly towards right hand side also we have got the V of S. So this term was okay, at least for the calculation of the ratio between Is as well as Vs. This term was okay and this term was also okay. So what we had to do, we had to drop this term out. There is no other way. And once you'll see which term this has been the initial condition or the initial current over the series RL circuit at t is equals to 0 minus, which becomes same as V is equals to of 0 plus. Could you understand? So deliberately I need to drop this out, and once we drop this out, I got the ratio between I of s divided by of V of s is equals to of 1 divided by of R plus of Ls. Yes. So that is what I used to say whenever we have been dealing any electrical network into the control domain where the study has to be made over the transfer function domain. What we used to do, the L is simply being taken as L of S, which we have seen earlier. The initial condition is again been dropped. Again I am saying I am not very happy while dropping this initial condition, but there is no other way. This has been the limitation of the transfer function. So I think the single question could have delivered so many important concepts regarding the transfer function, which starts with the ratio with the transfer domain only. You cannot take the domain of study into the time domain. Similarly, the system has to be linear as well as time invariant system. You can't have this system when you can't have this system. If you'll take those sort of system, you are not ready to get the ratio between ys as well as xs. Not only that, once you'll read their option, deliberately they have put a few more number of wordings along with that option. What it's been, all initial conditions are being 0. Many of the students would think, sir, why it's necessary, or whether we can manage without dropping the initial condition. No, whenever the initial condition do come, it would come separately, and whenever it comes separately, you cannot get the ratio between the output into the Laplace form to the input into the Laplace form. Could you understand? So just would like to have the input from each one of you. Could you understood almost a basic crux behind the transfer function? That is why I have taken this as a first question, and as it has been communicated earlier, yes, we are learning each and individual concepts through the question alone. So lump sum I had given a concept regarding the transfer function. If it is part is clear, just write clear over the live chat, and then we are ready to go ahead. Okay, Gayatri, the doubt clear, sir? No, that's fine. That's fine. In the same sequence, let me go ahead with the next question. Yeah. A system represents by the differential equation m d square x by of dt square f dx by dt plus kx is equals to of u of t. U of t. Yeah. The transfer function relating x of s and u of s is, the four different options were attached along with this problem. I need to get the best most answer for this given problem. The four different options probably must be visible on your screen, but anyways, for the sake of better clarity, let me read each and individual options word by word. It's been m divided by ms square plus fs plus of k, f divided by ms square plus of fs plus of k divided by of ms square plus of fs plus of k, 1 divided by of ms square plus of fs plus of k And probably this problem should not take more than 20 seconds to get rubbed out. Yes. Probably this has been the question, should not take more than 30 seconds. Because with the accuracy, we also had to increase our speed, but without losing the accuracy. That is why the fundamental has been dealt, and now it's the time to increase the accuracy as well as speed. So the first answer had been reached to me, and that has been D as per the Divya P. Anyone else apart from Divya? Nishant also says D. Amit also says D. Yes, the answer is supposed to be D. Why? It has been communicated earlier. Whenever we have been looking forward finding the transfer function of any system, what we do? D square x divided by dt square. Once we'll take the Laplace both other side, as the m is being a constant value, m would be taken outside, and here the Laplace of d square x by of dt square, although logically speaking it's gonna be s square x of s minus of s x of 0 minus of x dash 0, but x of 0 and x dash 0 is being an initial condition, and while calculating its transfer function, they had to get dropped out. So end of the day, the conclusion which we could derive in yesterday's class was, whenever you come across this situation, and if you are interested taking the Laplace of it, simply you have to write this as s square of capital X of s. May I know what had been the capital X of s? It's been the Laplace transformation of x of t, and the s square is a multiplier factor which is getting multiplied with the x of s, and the remaining component has been knocked off. So that's what I'm saying. Straight away, whenever this sort of problem do come in your mind, no, straight away what you do, the m is being a constant value, keep it aside, as the second order derivative coefficient was involved with this term, so obviously it's going to be s square. Here it's going to be x of s plus of f, and here it's going to be s times of x of s, and here it's going to be k x of s, and small u of t had been changed to the capital U of s. And as far as the transfer function is being concerned, the transfer function relating x of s and u of s, obviously you had to take the ratio, and once we'll take the ratio is simply gonna be, yeah, where should I be taking it? Let me take here itself. It's simply gonna be u of s, just a minute, x of s divided by u of s. I know many of the students would also have doubts, sir. How did you know which had been the output and which had been the input? I would show you. I would show you. So here's gonna be ms square plus of fs plus of k. Now I would like to ask from each one of you which had been the output and which had been the input, because that clarity must be there in your thought, no? Because I know many of the times the differential equation would be present over the question, but the student are not able to relate which had been the input and which had been the output. May I know, out of u as well as x, which had been the input and which had been the output? My dear friend, that is why I have taken an example of series RL circuit. The input was V of t, and because of input there had been the flow of I of t. So may I know what had been the input, what had been the output? So the I had been the resultant component and the V had been the input component. But with the help of differential equation, how did we know about it? Wherever the differentiation takes place, no. Wherever the differentiation of a certain variable takes place, most of the time that variable used to be output. And towards the rightmost side, most of the time the input used to be available or used to be present. Could you understand what I am saying? I know many of the students could have smelled with the help of the options which has been supplied along with this problem, but I would say this is not the current methodology to deal with this sort of problem. So I can say wherever the differentiation is being taken place, no, that variable used to be output, and similarly the rightmost component used to be the input most of the time, not always, most of the time. Could you understand? So you yourself would be able to understand over here. See, the differentiation was keep taking place of x of t. So the x of t is going to be output in time domain. So obviously in Laplace domain, it's going to be x of s. So as far as the transfer function is being concerned, I think this should also be there in your mind. The transfer function which you have been willing to calculate, you are taking the output to the input in Laplace format. So the output is going to be the Laplace of x of s and the input is going to be u of s. And now more than happily you can calculate the ratio of it. Yes. Anyways, this system has been a mechanical system. Let me go back into the class 9th physics. See, F. How the F can be related with the mass, can be related with the acceleration, can be related with the spring constant. You yourself would be able to understand. See, F is equals to m into a. May you know what used to be the acceleration? The acceleration used to be a rate of change in velocity. And what the v used to be, rate of change in displacement. And let's take the displacement is being written as d square x by of dt square. So the student who are from electrical and instrumentation should have a little bit knowledge of this mechanical modeling also, because sometime it's been asked in your gate examination. Could you understand? So this first factor states the force which has been applied to the system has been distributed in a form of the acceleration which has been found across a mass. Yes, acceleration which has been found across a mass. Not only that, in the same sequence, it's been a f dx by dt, yeah. And similarly the kx. Yes, so this has been the component of mass. This has been the component of damping. Anyways, at last topic is going to be this topic only. There I would be discussing a bit about the mechanical modeling, and here it's going to be a spring system. So in future you can have a system like this. Let's take it's been a hinge somewhere. A spring is being connected over here. It had a mass which is being connected. Let's take here we had a damper over here, and here the force F is being applied. Rather taking F, I can take this as U, and now this force got distributed over the damper, mass as well as the spring, and for that this mechanical system do come into the picture. Yes. So this is not the right time to discuss about this all. But yes, for the electrical and instrumentation people, I am going to discuss about this thing, and we are going to take around 3 to 4 standard mechanical system. We would try to deduce its time domain differential form of equation, and from there I would try to get its transfer function. So one thing must be there in your mind: control system is not only for the electrical, electronics and instrumentation, even it's also equally important for the mechanical, civil as well as chemical. Even in chemical, always there used to be one subject called the control system. They call it process control system, but there also it's very important, very important. So could you understand? So from here I can get one crux, and what is it? Most of the time I used to have one doubt, sir, which one would be the output and which one would be the input. Obviously the input would go with certain differentiation. So wherever the differentiation is being taken place in standard, you can presume those variable as output, and obviously the next is gonna be the input itself. So the second question is also clear to all of us. If you have any sort of doubt, you can ask over here. Otherwise, we are moving into the next question. Tell me, is that part clear? So here it's been the force has been damping constant, it's called F, and here it's been dx by f dt, and that's nothing but F. So here it's been a spring constant, the F is gonna be a damping constant, M used to be a mass over there. So as they have been constant, obviously they had been treated as constant. Yes. So in the same sequence, let me move forward and let me go into the next question. Just a minute. So here comes the next question. Deliberately I have brought this question in front of you, and yes, if you'll see the character of this problem has been experienced by electrical engineering services examination year of 2008. Tell me what would be the best most answer for this given problem. It would be the third question of the day. Tell me what would be the best most answer for this given problem. The transfer function for the diagram given by which one of the following, obviously you had a series RC ladder network and the output is being taken from the registry element R. The options are being, option A is being 1 upon 1 plus of SRC, B is being SRC divided by 1 plus SRC, C is being SRC divided by 1 minus of SRC, the D has been 1 plus of SRC. Tell me what would be the best most answer for this given problem. So the answer have started coming. As per the Sai Teja, the answer is being B. As per the Pranali, the answer is being B. Anyone else? Yeah. So 3 answers we have got it so far, and all of them are perfectly well. See, one of the catchy word which has been associated along with this problem is being the transfer function. Whenever the transfer function approach used to be taken place, I used to drop all of the initial condition. That means the initial voltage which was acquired by the capacitor or the initial current which has been acquired by the inductor. In that case, the impedance offered by the capacitance can simply be taken as 1 upon Cs, and similarly the impedance offered by the inductor can be simply taken as L of S. Keep in mind that's possible only and only if we have dropped all of the initial condition, and whether you are wanting it or not, but in transfer function you had been forcibly has been dropped it here, and R would remain R. Why so? Because R or the voltage and current relationship at registry load is being independent from time, so R would remain R. So the impedance offered by the capacitance is going to be 1 upon C, and similarly the impedance offered by the resistance is being R itself, because its behavior does not change time to time. And let's take the input which has been applied somewhere here. It's been R of t. In time domain we are saying, obviously in Laplace domain it would be called as capital R of S. And let's take the output which has been the output voltage across the registry element had been taken as C of t, obviously in time domain. In Laplace domain, it's simply gonna be capital C of S. So in this problem, we have been finding, or we have been in search of ratio between output voltage to the input voltage. in Laplace domain, keeping all of the initial condition aside, already we have done it, we had to use the voltage divisor rule. The voltage has been taken across the R, so the impedance because of R would come towards upside, and all of the series resistive as well as impedance element would come towards downside. So here it's gonna be RCS divided by of 1 plus of RCS, 1 plus RCS. So yes, B had been the best most answer. Yeah, that's fine, that's fine. The B is gonna be the best most answer. B is gonna be the best most answer. But if somebody would say the capacitance had the initial voltage of maybe 2 volt or 3 volt, in that case, this transfer function is not the appropriate approach to solve this problem, because the initial condition you have dropped, although which had the 2 volt, Agreed? So again, I would say the one of the important conclusion I can deduce, whenever the transfer function approach has been written along with the problem, simply the impedance offered by the capacitance can be taken as 1 upon Cs, and similarly the impedance offered by the inductance can be taken as L of S. But this should not be done when you have been doing the transient analysis, because in transient analysis we cannot drop the initial condition, we also give the equal weightage to the initial conditions also. Is that part clear? In the same sequence, let me move forward. Let me go into this question have come in GATE electrical year of 2000. The problem was framed by IIT KGP, IIT Kharagpur. Anyways, let me expand this problem. Read this problem carefully and try to get its best most answer. See what the problem states. Probably if it is not visible, let me explain this problem. A linear time invariant system. Now, this thing must be clear to all of us, that why bar they have been referring the linear time invariant system, because if they wanted to exploit the concept of transfer function, there is no other go. The system has to be a linear time invariant system. Linear time invariant system. The problem says a linear time invariant system initially at rest. May I know what does that mean by the initially at rest? That means initially it does not carry any of the energy. When subjected to a unit step input, given a response y of t is equals to of t into e to the power of minus t, for t greater than 0, the transfer function of the system is. The 4 different options were attached along with this problem. 4 different options were attached along with this problem. Tell me what would be the best most answer. What would be the best most answer? Let me bring this problem towards working board and we would try to smash that problem there itself. Yeah. Tell me what would be the best most answer. So the answers have started coming. Few of them are saying A had been the answer. Few of them are saying the C had been the answer. Tell me. So let me solve this problem. So here starts the solution. Obviously, system has been an LTI system. And from this problem, you wanted to get its transfer function. And whenever the transfer function approach has to be used with any sort of system, the system has to be an LTI system. LTI system. And at the same time, whenever the transfer function used to be calculated, all of the initial conditions are getting dropped. Until and unless you are not dropping the initial condition, you may not get the ratio between the output to the input into the Laplace domain. And that is why it has been clearly said that initially it is been at rest. That means initial condition is been 0. That means all of the favorable conditions are being satisfied, which states yes, the transfer function approach can be used. Transfer function approach can be used. Now, once you read this problem carefully, you'll get to know you had a system. The input was applied to the system. Let's take here, it has been the output terminal. Input is being R of t, the output is being C of t. What the problem states, at very beginning, the input was a unit step input. That means the input was a unit step input, which was U of t. And when the input was a unit step input, the output was t into e to the power of minus t, and there is being valid only for t greater than 0. What does it mean of it? That means it's been t e to the power of minus t u of t. Yeah. And now they have been looking for the transfer function of the system. May you know what used to be the transfer function of the system? My dear friend, if the input is being unit impulse, whatever the output you get, no, whatever the output you get, the Laplace of that output, let's take the output which you have been getting, it's been c of t. The Laplace of that output used to be the transfer function. So somewhere, if you want, you can write the transfer function of any system is being the Laplace form of its impulse response. Laplace form of its impulse response. That means the input has to be the unit impulse input, whatever the output you get in time domain, if you convert into the form of Laplace domain, you get its transfer function. You get its transfer function. Could you understand what I am saying? So more or less, this problem has been designed in such. For the ut corresponding output is being known to you. Now you had to get the output corresponding to the del of t, and from there you had to take the Laplace transformation. You'll be getting the transfer function. You'll be getting the transfer function. So the answer had been C, C, A, C. We'll see what could be the best most answer. Just try to understand in this way, my dear friend. May I know what used to be the Laplace of u of t? It's been 1 upon s. It's been 1 upon s. That means towards the output side, when I could have multiplied t of s, just try to understand this way, when I could have multiplied t of s with 1 upon s, obviously the c of s could have been produced. Now the inverse has been taken with that c of s, and from there I got this output. From there I got this output. But now what's happening? Did you understand? Now 1 upon s is vanished, because once you'll take the Laplace of del of t, it's simply been 1. So may I know what's the change you are experiencing? Initially, this factor have come because of the multiplication of t of s with 1 upon s. But now this output would come because of the multiplication of t of s with 1 itself. What does that mean of it? That means put together, the response would change according to the absence of 1 upon s. May I know what does that mean by the absence of 1 upon s? That means the s is going to get multiplied, and as the s is going to get multiplied, there would be the differentiation in time domain. Could you understand what I'm saying? So for ut, if the response is being t e to the power of minus t, so for the del t, the response is simply gonna be differentiation in time domain t into e to the power of minus t, because here 1 upon s was present, but here 1 upon s was absent. That means once you wanted to retrieve the response because of del of t, the 1 upon s has to be extracted out, it has to be vanished, and that's possible only s has been multiplied. And as we know, s used to get multiplied in the Laplace domain. There used to be the differentiation in time domain. There used to be the differentiation in time domain. Could you understand what I'm saying? Could you understand what I'm saying? So here it's simply going to be d by dt t e to the power of minus t. We'll take differentiation by parts. Let me differentiate t with respect to the t first. So the factor which had been left out in my hand has been e to the power of minus t. And now, secondly, what we are doing, t has been kept as it is, and now it's turn to take the differentiation of e to the power of minus t. So here it's been t e to the power of minus t, and this has been the response because of unit impulse. And once you'll take its Laplace, you'll be getting the transfer function of the given system. So the Laplace of e to the power of minus t, it would be e to the power of minus at, where the a is been 1, and as it's been a minus, it's simply going to be 1 upon s plus a, which is been plus 1, minus, because of t, which we have seen earlier, what used to be the outcome over here? Here I would be having differentiation in Laplace domain of 1 upon s plus 1. Could you understand what I'm saying? And if the t has been raised to the power of 1, this component used to be the odd, and similarly if the power used to be even, this component used to be plus. Anyways, minus and minus has been knocked off, and simply it's been plus. So what's been happening over here? 1 upon s plus 1 plus s plus 1 has been raised to the power of 2. At next, what's happening over here? S plus 1 would remain as it is, differentiation of 1, that would become 0. Next, 1 would remain as it is, differentiation of s plus 1, and that's going to be 1 itself. So simply it's going to be minus of 1. minus of 1. So what we can do over here, minus of s plus 1 had been a common factor over here, or you can say plus also, plus. So the factor which has been left out is going to be 1, and here it's been like this, 1 divided by of s plus 1. So end of the day, 1 upon s plus 1 had remained as it is. Once we'll take the LCM of it, it's going to be s plus 1. And now the s plus 1 gets multiplied with the 1, it's going to be s plus 1. Going to get subtracted with 1, it's going to be simply s. It's going to be simply s. So end of the day, once we'll multiply them together, so the best most answer which we are supposed to get, it's going to be option C. I know many of the students had done a mistake over here. Many of the students had done a mistake over here. So from here, the important most conclusion which we can retrieve, if you know the output because of unit step, in that case, the output because of unit impulse is simply gonna be the differentiation in time domain. So what I'm saying, if you had the same system, the system has not been changed. So if you had the same system for the unit ramp input, if the output is being C of t, in that case, if the input has been changed from unit ramp to unit step, the output is simply going to be C dash t. And similarly, if the unit step has been changed to the unit impulse, the further differentiation would be taking place. This sort of problem, or the based on this concept, many of the times the problem have keep coming. In this problem, what they have given? They have given the output during the input which has been fixed to the system was u of t, and they have been asking what would be the transfer function. How did I calculate this? Obviously, once we know this c double dash t, or I can say once we know the output is in correspondent with the input as the unit impulse, I will take its Laplace, I will get its transfer function. Yeah. So probably this concept must be clear to all of us. Obviously, 2 or 3 more different varieties of methodology we have to solve this problem. You can use either of them. Is that part clear to all of us? I would like to have the input from each one of you. Is that part clear to all of us? And you can expect this sort of problem in future. It had been an important question. Tell me fast. Because only 1 hour we are going to spend together. Yeah, in the same sequence, let me take the next question. No reply, whether you are getting this concept or not. Okay, let me explain once again what I am saying. Just try to understand in this way. In this problem, they have given the response of the system, and that too in time domain, when the input was a unit step input. And now they have been asking to find the transfer function of the given system. What used to be the transfer function of the system? The transfer function is nothing but the Laplace transformation of the output when the input which has been applied to the system is being unit impulse. U of t, corresponding to the u of t, the output is being taken. Now you have to just take its differentiation. You'll get to know what would be its equivalent response when the input is being unit impulse. You just take its Laplace. Now, one more homework I would like to give over here. See, initially the input was 1 upon s. Now that 1 upon s has to be vanished over here. So in Laplace domain also you have to do the calculation. Here everything had been taken with the help of time domain analysis, differentiation in time domain. At last I have taken its Laplace. So I would request to each one of you, all of the students should also try to solve this problem at the Laplace domain, where they would take y of s first, and then they would replace 1 upon s with 1, and from there you had to get its transfer function. I would request to get the answer from that method also. Definitely you are going to do the mistake from that method. That's what I am insisting to do, that way of calculation also. In the same sequence, let me go forward and let me take the next question. This problem has been experienced by the gate instrumentation. Year of 1999, the problem was framed by IIT Bombay. Yeah. The relationship between the input xt, it has been clearly written. Xt as well as the output y of t of the system is being given. And as far as the transfer function is being concerned, it's gonna be the ratio of the output as well as input into the transform domain. And it has been clearly said, it has been the input, it has been the output. So we have been looking for the ratio of output to the input in Laplace domain. Tell me what would be the best most answer for this given problem. What would be the best most answer for this given problem? Again, we would take the Laplace both other side. So what I am going to do over here, taking Laplace both side. See, once we'll take Laplace both other side, again the same concept must be there in our mind. The initial condition has to get dropped, and once the initial condition are getting dropped, no, so simply it would be left out with the s square. A small y would become a capital Y, and earlier it was a function of t, now would change to the function of s. Now, many of the students would also have doubts, sir, whether it's been a time variant or invariant system, my dear friend. If something is getting multiplied with the t, then only it would become a time variant system. This particular form of the input is not been a form of time variant system. It's been a time invariant system. Even if you'll try, you'll get its transfer function also. See, x of t minus of a stands for e to the power of minus as, which had been e to the power of minus 2s, x of s, and again the same process has to be followed. Initial condition has to be dropped, so it would be left out with the s square alone, and here it becomes x of s. And as per the problem, we have been looking for the ratio of y of s divided by of x of s. So here it becomes e to the power of minus 2s plus of s square divided by of s square. Obviously, we can do one thing. The s square had been the common component towards the numerator as well as denominator. We can knock them out. It becomes 1. Yeah. 1 plus e to the power of minus 2s divided by s square. So whoever have got the answer as A, that's gonna be the best most answer. Yeah, perfect. So again, I would say a few of the critical points. First thing, many of the students would stuck over this point itself. Sir, whether the transformation is possible or not? Yes, it's possible, because if it would have been 2 times of t, maybe minus t times, or maybe t square, in that case you cannot get the ratio between ys as well as xs. It's again been a LTI system. Again and again I'm saying, my basic responsibility is not to teach about the LTI. That would be discussed when we would be discussing about the signal system. But yes, at least we could frame the transfer function out of the given problem. And I can say one thing, whenever you are able to calculate the transfer function for the given system, no, but understood, system would be LTI system. Agreed? So would like to ask from each one of you, should I increase my speed from next class onwards, or whether everything is okay? Should I increase my speed from the next class onwards? Because I also had to give a little bit basics behind the each and individual question. Then only you are going to learn the concept through the question. Otherwise, taking the question would not be helping any of the students who do not have any idea about the control system. So I want the input from each one of you. Should I be increasing the speed, or whether it's okay? Only one response we have got it so far. Speed perfect, sir. A little, yes. Okay. Not much, please. Speed is okay, sir. Yes, sir. Need to increase the speed. Speed is okay, sir. We'll see. Because the mixed input has been found over the live chat. Uh, I will plan accordingly. I will plan accordingly. And at any case, I am going to take around 6 to 7 number of problems at daily basis. At daily basis. So this is all about the today's class. In tomorrow's class, we are going to take few of the critical questions based on the concept of steady state response. That's the first thing. Once we are done with the steady state response, we will be taking few number of questions based on the concept of the initial as well as final value theorem. I know many of the questions has been framed in such a way that question would be trapping my student. So that is why I am going to take around 2 to 3 number of questions. Okay, so this is all about the today's class. Definitely the next curriculum must be known to all of us. You know that curriculum, no? Otherwise I can show you once. Yeah, this used to be our class timing. So you can have this reference. So the student who are from electrical electronics instrumentation would have a better idea. Electrical machine, obviously for the instrumentation as well as electrical, we used to have exactly at 1 p.m. 5 days in a week from Monday to Friday. The class would be taken by our sir. And similarly, the power electronics, again, it would be taken by, again, the same sir who used to take the electrical machine. The classes would be twice in a week, and that's nothing but the Saturday and Sunday. The Bhanu sir is going to take this class. Control system would be taken by me. That would be in daily basis. Precisely at 3 p.m. we would be meeting on our Gate Academy Global. Obviously, it would be for the electrical, electronics, instrumentation, all three. Only for the electrical instrumentation, only for the electrical, it's for electrical, electronics, instrumentation, all. And then PSA that used to be taken place at 6 p.m. daily basis, it's only for the electrical alone. The class would be taken by the Vishnu sir. EMFT, the EMFT would be taken by the Karthik sir, and again it would be in daily basis. Starting 7 to 8 days, it would be common for the electrical, electronics, and instrumentation, all. And from there onwards, it would be excluded for the electronics alone. And the network analysis, 9 p.m. daily basis, had been taken by Diptanshu sir. So this would be your daily basis agenda. And you must follow this agenda very well. End of the day, probably, you would find yourself very strong in your technical education. Till then, bye-bye. Take care. Good night.